couple of lessons.
This is a very easy lesson.
Yeah.
Teaching on iPad.
They're so swag.
All right, there it is. All right. We're gonna talk about L'Hopital rule. So, shout out to Deborah and Kelly and Jorge. Hopefully, you feel better, Jorge, at home. Who else I'm missing? Oh, Madden and baseball tournaments. Good luck on your baseball tournaments. But L'Hopital rule are super important. So L'Hopital. So L'Hopital is a French mathematician around Newton's time, 1661 and 1704. This is a very, very important mathematician. So L'Hopital rule says basically, if anything that indeterminate, you can apply L'Hopital rule, which is you study if the function go into a specific C, and you will reach indeterminate form. If it's indeterminate form, then you can apply L'Hopital rule. So what are indeterminate form? Let's talk about indeterminate form. We already done one beginning of the year. Indeterminate form is 0 over 0. We done this beginning of the year. Do you remember that?
Yeah.
Infinity over infinity. We probably never done that, but we're going to do that today. The next one is 0 times infinity. That's also indeterminate. 1 to the infinity. 2 more. 0 to the 0. And infinity minus infinity. And that's it. There are 6 different ones. AB exam is very, very lucky because AB exam only including those 2. BC exam, you might get difference between this part is going to be, and not very often, still it's more tested more the first 2 than last 4. So the first 2 is AB. You only need a concern AB exam. What's L'Hopital rule?
Are you asking us?
No, I'm gonna go over it. Don't worry.
There's such a pause. I thought you were waiting for someone to answer. I was like, man, let me take a stab at it.
That's okay. If f of x and g of x are all differentiable in this formats, let's say x approach to c of f of x over g of x, if they reach indeterminate, so if this is indeterminate, if it's indeterminate, then you say limit x approaches c. Instead of talk about the function, we can talk about the rate of the function, which is f prime of x over g prime of x. Because if the function doesn't work, you can look at the rate. The rate, which is derivative. Now, please don't confuse this with quotient rule. It has nothing to do with quotient rule. Quotient rule is low d high, high d low over low low. But this one, just take a derivative of the numerator. And then take a derivative of the denominator. And then reach the same number again. And that just go to show you that's going to work. Got it? For example, beginning of the year, we did this question, limit x approach to 4 of x squared minus 2x minus 8 over x squared minus 16. In beginning of the year, what do we do? Factor the numerator and factor the denominator, right? That's equal to limit x approach to 4 of x minus 4, x plus 2 over x minus 4, x plus 4, right? This is the beginning of the year. That if you plug in 4 in here, so 4 plus 2 is 6, and this is over 8. So that down to answer 3 over 4. So this is the beginning of the year. Because we don't have much tools. Let's try L'Hopital rule. We says limit x approach to 4, x squared minus 2x minus 8 over x squared minus 16. Now, what do? We plug in 4 in here. We find out this is 0 over 0. Like before. Now, this is not a proper way to write it on FRQ. I'm going to teach you later. Do not write down 0 over 0 in FRQ. FRQ, you have to write it in a specific rubric. So FRQ need specific rubric. Okay, but right now it was assumed that this multiple choice. We can take a derivative of the top. So limit x approaches c. Usually I don't have to do this, but I'll show you what happened so that way you don't get confused. What is the derivative of x squared minus 2x? 2x minus 2 over 2x, right? Now, for those of you guys are bad at math, you could probably think about 2x cancel out. They cannot cancel out. Do not cancel out. You're going to plug in 2 times 4 minus 2 over 2 times 4. That's equal to 8 minus 2 over 8. That's equal to 4 over 8. That's equal, no, 6 over 8. That's equal to 3 over 4. Do you see they give you the same answer? And you're going to be like, yeah, beginning of the year still seems like a little bit easier. Now, remember, not all functions are factorable. Because you might deal with e to the x. You might deal with natural log of x. You might deal with all those functions. Got it? So in this case, you're going to get the same answer. Now, I would tell you, L'Hopital rule is not good for certain situations, though. It has to be indeterminate form. This is non-debatable. It has to be indeterminate form in order to use L'Hopital. But I will say there was a weak link. So weak part of L'Hopital rule. Usually something to deal with radicals. If I have something with radical, I won't use L'Hopital rule. Just because if you take a derivative of radical, it gets very messy. So usually I will do conjugate. So this, if you see radical, I will not do L'Hopital rule. I will actually do conjugate instead. This is a better possibility. So weak part of L'Hopital rule is deal with radicals. Anything with radicals, not like radical. It's like radical plus something. Let's say something like x plus 2 on the numerator or denominator, something like that. Now, just square root 2 is not too bad, but square root something plus something that you need to do conjugate beginning of the year, I will still do conjugate. Okay, so not just square root 2. Square root 2 is fine. That just show you that. Okay, so now why do we need use L'Hopital rule? Because not all functions are factorable. For example, limit x approach 0 of e to the 2x minus 1 over x. Now let's talk about rubric for FRQ. Rubric for FRQ, you had to write down as limit x approach 0 of e to the 2x minus 1. You had to write down the numerator. What happened when they reach 0? What's e to the 0? What's 1 minus 1? Good. You write down like this. That's just 0. So on FRQ, you had to write down this statement first. FRQ only, not multiple choice. Remember, on FRQ, you have to write down this statement before you apply L'Hopital rule.
Why?
Huh?
Why?
I don't know. That's just a rubric. You cannot just say 0 over 0. Like for me, I just rather write down 0 over 0. But the thing is, on FRQ, they have this specific rubric. There's 1 year, nobody got a perfect score. Because this rubric. Usually there's 1 student or 2 students have perfect score. But that 1 year, nobody got one. Because nobody fit in the rubric, unfortunately. Nobody in the world. Yeah. Usually in the world, they usually have 1 student or 2 students got a perfect score.
Did you get a perfect score?
No, hell no. Not even close. Like if I will say if my AP exam, I probably got 80, maybe 82 out of 108. I think that's probably if I would guess. But you only need a score above a 70 to get it 5. That's how it matters.
Do they let you know if you get a perfect score? Like
They will let you know. You are the only people who will get actual certificate from College Board. So that's a very special. No, not even close. Sheila, I think she got it. But again, that's Sheila. But she's like, I think I got a perfect score. But
no certificate, no perfect score.
yeah. No, we were actually was gonna prank her.
That would have been so funny.
We actually have the whole letter of the College Board, and we just changed her name.
Why didn't you do that?
I have no heart to do it. No. First of all, it was too late when they finally finished the letter.
Yeah.
But we didn't because they already announced who's got a perfect score. It's some kid in Boston, and she's not some kid in Boston.
Y'all get a perfect score letter, just know it's probably from me. Can you do that to Deborah, please? Oh my god. Please, that would be so funny.
So she's listening right now.
She's definitely not listening right now, let's be perfectly honest. That would be so funny though. Please. Yeah, she actually will.
Yeah, so we like they actually like got a template, and then they went to see the whole letter, and they ran out exact same way, and they have the exact same signature, Photoshop everything. And we were gonna prank her, but it would be so funny.
That would be so funny.
But they give it to me like a week too late. They worked on it for a whole week too.
Whole week. How many kids were working on this?
3 kids, Jackie
A
and
whole week.
Miriam and Zafara. They will research how the letter's supposed to word it and how everything. But yeah. So you have to write down this rubric, unfortunately, in FRQ. Now, if you did that, you can just write down via L'Hopital.
Do we also have to write?
No, you can just say L'Hopital, and or you can do this. D to the dx. They know that's L'Hopital rule, so you take a derivative at the top, and take a derivative at the bottom, And that's gonna give you 2e to the 2x over 1. When limit x approach 0, this one's gonna give you 2 times 1 over 1 is equal to 2. So the answer is 2. Now remember, this is not factorable. I mean, this actually is factorable, but you don't know how to factor it. Actually, do you know how to factor e to 2x minus 1? It's actually interesting.
Come on, someone's got. Anthony?
But it doesn't cancel out anything. Even though it's factorable, it doesn't cancel out. It's a difference of square. It's actually e to the x plus 1 and e to the x minus 1 over x. Because e to the x times e to the x is e to the 2x. So it's actually factorable. But it doesn't help you. Doesn't cancel anything. So it's not. Yeah. Now this one's rich infinity.
Wait, can we just start on it?
You can start. Now for FRQ, just write down the rubric. For rubric for FRQ, unfortunately, that's how they want. But I have no justification. I never even be a grader, so
Why?
why would I want to grade? I don't even want to grade my own paper. You know how much like they actually pay teacher to stay in a hotel grade all this paper, and they have unlimited bar access. So people getting drunk over there.
And then grading my test.
Yeah. But think about it. You grade half-min tests by hand, and you grade the same question over and over and over again. So each day you grade at least like 2,000 of the same questions.
I mean, someone's got to do it.
It's a disgusting job.
It's a disgusting job. Like English.
I wish everybody turned in a blank paper. All I gotta do is mark 0.
Friend, we took AP stats together, and he like would always like for our FRQs he would just write NA on them, and then he'd like give them back to our teacher, and our teacher would get so mad at him. He'd be like, what do you mean, like not applicable? Like you have to like fill it out. And he was like, yeah, like I don't know, I just started like doing it, and then I just said I didn't want to.
Cass?
Yeah.
Cass will be pissed.
Oh my god, Cass will get so mad at this kid.
Okay, so if I go according to rubric, it's gonna be infinity over infinity, but I'm not gonna write down the rubric, but you know what you need to write down. Just say limit x. I'm gonna write down. Natural log x equal to infinity. Limit x approaching infinity of x is equal to infinity. I'm gonna take a derivative for this, top and bottom. So d to the dx of ln of x and d to the dx of x. What's d to the dx of ln of x? What's the derivative with ln of x?
1 over x.
1 over x, good job. And this is 1. Limit x approach to infinity. So that is going to be limit x approach to infinity of 1 over x is equal to what? 1 over infinity is what? 0. Thank you. It's 0. The answer is 0. Sometimes you can apply L'Hopital rule more than once. So this one's negative infinity e to the negative x. Let's see, what is it? If you reach negative infinity, no, it has to be a fraction. That's another thing. You had to make it become a fraction. Now this is a fraction. You don't want to change it. It's rich negative infinity in this time. X squared, yeah. I heard Sheila just never show up in first period. Miss Davis class.
Gotta keep them on their toes, you know. Just kidding, I just missed the last question.
You had to apply more than once sometimes. Sometimes you might have to apply a lot of times. On the competition questions, usually they will sometimes you will apply twice or 3 times. Yeah, that's how it is. On AP exam, sometimes apply twice is pretty normal. So if I reach infinity, it's like I'm gonna do infinity over infinity. I'm not gonna write out a long rubric because negative infinity square is gonna be infinity. E to the negative infinity is e to the positive infinity is still infinity. So I'm gonna take a derivative top and bottom. I'm not gonna write down d to the dx anymore. You should write it down. D to the dx of x squared over d to the dx, because that way they know you did L'Hopital rule, or you're gonna write down says using L'Hopital rule. Then you don't have to write down. So limit x approach to negative infinity. This equation is gonna be 2x negative e to the negative x. Did you guys do that? Then you reach infinity again. You're gonna get infinity over infinity, obviously. Actually, hold on a second. It's an infinity over negative infinity, but that's still the same thing. Then you're gonna say that's it was L'Hopital rule again. So L'Hopital. If you don't want to write down d to the dx, use L'Hopital rule again. So it'll be 2 over e to the negative x. Now, if we reach infinity, in this case, it'll be 2 over infinity. That's equal to 0. So the answer is 0.
After you got infinity over negative infinity, why did you do L'Hopital rule again?
Because that's still infinity over infinity. Because if it's anytime indeterminate form, it's still, it doesn't matter if negative or positive. The negative is a coefficient. So it's still infinity over infinity, just a negative of that. So it's still indeterminate form. That's still equal to 0. Limit x approaching infinity here. E to the negative x over square root x. Now this one's actually a special case. The problem with this case is what? What do you think is the problem in this case? Yeah, e to the negative x. What's e to the negative infinity? What's e to the negative infinity, guys? No. E to the negative infinity? No. 0. Thank you. Remember that graph I told you guys that you had to memorize? This is e to the x. If you go to negative infinity, it's going towards 0. It's plateau into 0. So 0 times infinity in this case. Therefore, it's one indeterminate form. But in this indeterminate form, I need to change to another indeterminate form in order to use L'Hopital rule. What's one requirement of L'Hopital rule? It has to be a division. It has to be a fractions. Luckily, we can turn this to fractions because I can get square root x e to the x. Now, remember when I say radical? This is not a radical I'm thinking because derivative of this one is still pretty easy. It's more like radical combined with the other like things. You have to do conjugate is better. This case, I will still use L'Hopital rule here. Now let's take a derivative top and bottom. Limit x approaching infinity. In this case, it's going to be what? 1/2 x to the negative 1/2 over e to the x, right? And that's limit x approaching infinity. It's going to be 1 over 2 square root x e to the x. Because this is negative, I can move it down. Now 1/2, that's going to be 0. So the answer is still equal to 0. And you're going to be like, you could have told me 0 times infinity is always 0. But you have to be able to justify why they are 0. It's true like that sometimes. is true to have different number, possibly. So you cannot excluding those things. Now, sometimes you need to have a vision. What I mean by vision is sometimes you have to be able to see things. I'll give you a simple one. Limit x approach infinity of e to the, let's just say it's x to the 10 over e to the x. Now I can write x to the 100. The answer is always going to be the same. Can you tell me what's the answer here? And why? And no, the answer should not be I have to take a derivative 10 times. Yeah. I could write 100, so that means you have to take a derivative 100 times. Well, sometimes like this, you just need to have vision of what happened. I just learned that word yesterday. What is this vision? You gotta have vision. You were the one that's saying that.
Me?
Yeah. You were saying something like, I don't know.
I don't remember saying that, but I probably did something wise like that.
Okay. So what happened is this is infinity over infinity, right? Now what will happen? If I take a derivative one time, it's going to be 10x to the 9. On the bottom is e to the x. It's still infinity over infinity, right? I'll take it twice. 10 times 9 times x to the 8 over e to the x. The bottom part is still e to the x. Now, if you realize the bottom is always e to the x, numerator, if you take enough derivative, you'll eventually go to a constant. Does that make sense?
Yes.
Because x to the 10, if you take a derivative 10 times, Mia, are you okay? Sorry. If you take a derivative 10 times, it's still going to 0. Then the numerator is gonna, the denominators outrun the numerator. Because on the bottom, it's gonna go exponential. On the top, it's not exponential. It's x to the 10th degree. So if you take 10 derivative, eventually you're gonna get 10 factorial over e to the x. What's 10 factorial? It's 10 times 9 times 8 times 7 times 6. And eventually this will go to infinity. 10 factorial is still a number. So that's still equal to 0, regardless of what happened. So that's equal to 0. So those are special cases. Now you have to have a vision, see what happened. E to the x, you take 10 derivatives, still e to the x. X to the 10, if you take a 10 derivative, it's going to constant. It's constant, bottom's gonna go infinite, still gonna be outrun eventually. The numerator could be x to 1,000. It doesn't matter. 1,000 factorial is a very big number. But eventually e to the x will outrun x to 1,000. Somewhere very, very far away. Like infinite. Nathan just dropped the pen. Yeah. All right. So how much time I have? Good. We're going to talk about one special case. You don't need to know. I'm just going to illustrate to you. It's not going to be on your test. You don't need to worry about that. But I do want to show you 1 to the infinity part. So this is on the thing. So infinity of 1 plus 1 over x to the x. If I plug in infinite, it's going to be 1 plus 1 over infinity to the infinity. And that's equal to 1 to the infinity. Does that make sense? Because 1 over infinity is 0. Now, you're going to say 1 to the infinity is probably 1, right? We're going to prove that isn't so. What we're going to do is we're going to prove that. Now, it's not really a 1 if you be careful, because if you plug in 1, what happens? It's actually 2 to the infinity. It's just when they reach infinity, this one becomes very small. So it's really like a 1 plus something. right, to the infinite is equal to something. So we're gonna call this y. We're gonna call this y. So the y equal to limit x approaching infinity over 1 plus 1 over x to the x. We can call it y. Now, remember we said in order to do L'Hopital rule, it has to be a fraction. Is this a fraction? Is this a fraction? No. Okay, but not only that, this is not a fraction. You have an exponent that's a variable. What do we talk about if you have exponents variable? What do you do? Natural log. Very good job. Natural log on both sides. So natural log of y is equal to limits x approach infinity of x natural log of 1 plus 1 over x. Okay. Now, in order to use L'Hopital rule, it has to be a fraction. Is this a fraction? Well, this part has some type of fraction, but it's not really a fraction. So what we're going to do is we're going to use some math magic here. It's a witchcraft. No, it's not. So here is we're going to use x approaching infinity. Here we're going to say limit of 1 plus 1 over x. And we're going to say here it's going to be x to the negative 1. Why? We switch to the bottom and make it become negative 1 power. This is the first time we ever do that algebraically. Because we usually move to the top to take a derivative. But now we move to the bottom so we can set it as a fractions. Not only that, it's going to look like this. ln of 1 plus 1 over x over 1 over x. Does that make sense? And you say, oh, okay, yeah, looks good. It looks like a fraction now. Now I can apply L'Hopital rule. So if I apply d to the dx here, d to the dx. The cool thing is this, is limit x approaching infinity. Like I said, this is not going to be on your test. It's going to be, this is u, so it'd be u prime over u. So what's derivative of 1 over x? It's going to be negative 1 over x squared, right? Over 1 plus 1 over x over negative 1 over x squared. Because derivative of this and this are exactly identical. What happens if they're identical? Now you can keep change flip. This will cancel out exactly like that. It becomes x approach infinity of 1 over 1 plus 1 over x. But don't forget on the left side. What is the left side? It's left side y. It's natural log of y. I didn't take a derivative. I only take a derivative of the numerator. I take a derivative of the denominator. It's not a quotient rule. Natural log of y is never did anything. That's just on the other side. What happened if it reached equal to infinity of this part? Does anybody know? What happened when it reached infinity? What happened if this part reached infinity? Let's start out by it's just 0. Now is 1 over 1 plus 0, right? Does that make sense or no? And that's just equal to 1. Natural log is 1 is equal to 1. Therefore, you either both sides, it's actually e. So this is a definition of e. This is definition of e. All right, make sure you prepare for Monday's retake. Somebody post a link of the old test on the things. Go back and review it. It's gonna be similar, different number. Okay. It's gonna be not the same test. It's gonna be different number.
I'm still.
But
I was there.
RJ, you back? RJ, what's wrong with you? Why are you so tired? What test? Graham? Now, who's a better teacher, Palm or Graham? And there's a pro too. Palm's a
He's
Palm.
the hardest, but he has the highest pass rate.
Oh, really?
But it's like class is the hardest.
But it seems like everybody in love with Pro, right?
Yeah, because he's the easiest.
Oh, really?